Hello everyone. DSA is easy once you know the pattern. Today I'll be solving LeetCode problem number 76. This is Avyan Verma. So let's get started.
So let's get started. Minimum window substring. So minimum window substring here. This is the problem tells us. Okay, this was something that I did in the previous video where S string is A D O B E C O D E B A M C and the T string is A B C. Now the question tells us that we need to find a range inside of the S string where it contains every character in T and every character is included in the window. How do we do that? If it's not there, obviously the answer is going to be this string, but otherwise the answer would be okay. Now to understand the first thing, we need to understand the most naive approach. Once again, the most naive approach for this problem would be to obviously once again generate all substrings. Generate all substrings would be the most naive approach here, right? Because that is something that you need to understand, that whenever we are doing something like this, we are mostly focusing on something that's when you have, let's say, A here. What we are doing is that we have A here and then we have AD here and then ADO here. So we are getting all the possibilities here. Naive approach is something which we do to get all the possibilities, and in those possibilities we can check, because that definitely will be having a minimum substring as well, because it's generating all the substrings. All right. Now, but this is going to be a problem here, because if we just like in the previous video, if we try to know about the time complexity of this video of this silly approach, that would be probably n to the power 3 or maybe n to the power 4 as well, right? Now the second approach is the better approach. Second approach here would be to use, the second approach is to use a hash of 256 characters. When you use the hash of 256 characters, what you are doing is that you are basically checking if that character has been ticked off or not. For example, let's say you are inside of A, B, O, B. Now this is something that is very important and which will give us a basis for our optimized approach. Okay, because if you are able to think of a better approach than from the naive approach, because the whole process is to get yourself comfortable with N3, then move to N2, and then to optimize it to N. Or it could be in just till N2 as well, but right now it can go till O to the power On. Okay. Now here, where we have A, D, O, B, E, C, O, D, E, B, A, N, C. Here, as I told you, that what we're going to be doing is, first we're going to be iterating the second string that is given to us. These are all uppercase characters. So the A, B, C. We're going to first iterating it and storing it inside our hash. And we're going to be filling the whole 256 array with zeros, where A, now that we have iterated it, A would be 1, B would be 1, and C would be 1. Okay. So because they are 1, that means they have been pre-inserted. Okay. Remember this line. They have been pre-inserted. Okay. So when we go on to here, okay. So we're going to now iterate it. So this is the I and this is J. We're going to iterate now A. Okay, A, we can see it has already been inserted, right? It has already been inserted. Okay, so as we know that we have already inserted A here. Okay, now we are on our S substring. When we are on our as substring, we are on A here because it has already been pre-inserted. We are going to subtract it by 1 and it is going to become 0. Okay, now the number was positive. Whenever the number is positive, remember, this means it has been pre-inserted. When you change from a positive to a not positive number like a 0, you have to increment a count variable. That's what you have to do. This means that you are getting the numbers, you're getting the characters inside of our window, inside of our range. You're capturing them. Okay. Then J would be moved to here. Okay. So now you're going to say, okay, D is -1. Then J is going to be here. Then O is -1. Then B. Then now B becomes from 1 to 0. This gives you 2. And then J is here. And then J is there. E becomes -1. And again C becomes 0. The count becomes 3. Now, wait here. Now, as you can see, the count is now equals to the length of T. So by this method, because to understand this approach, to check that our range actually has those characters, we need to be able to check if number one, all the elements in T have been marked. Number one. Okay. Number two, how do we know, like, even if we have this kind of, even if we are storing the number that we have got, how do we check? So to check those things, we are going to basically, what we are going to be doing is we are going to be basically counting it and counting the length of the T here. So now that we've got length of the checked numbers as 3 here, we have got the checked numbers as 3 here. So now we know, okay, we have fulfilled the condition, and now we have all the substrings, we have all the characters. Now we can actually have another variable and store the length of this. It will be j minus I plus 1. Okay. Now because now the count is equal to 3. What we're going, because we need to find the minimum substring. Because we need to find the minimum substring, we are going to be shrinking. Not shrinking here. This is not a shrinking one. This is like a better approach. So my bad. Sorry. Not shrinking here. This is something that this is the only that is the only. So first you have to create a hash. Second, you have to iterate with E, J, all the possibilities, and check using count and hash. Okay, count and hash. So here, if I tell you how it's done, this would be E, C, O, D, E, B, A, and C here. Now A becomes 0, B becomes 0, and C becomes also 0. Okay, we were on here. We were here. So now J is here. I see. Now we have got our count equals to K. Whenever count equals to K, we are going to increment the I, and J will again be at this position. Okay, so we're going to start from here. And we're going to count till the n-1 and repeat the same process again. 1, 1, 1, and then obviously iterate the T again. First we're going to iterate the T again. So, and insert inside of our hash, and then again. So our I is here. So D is again -1. Then O is -1. B is -1. Now B is going to from 1 to 0. So count is equal to 1 now from 0. Then J is here. Then C is here. Okay, so now C is going to be changed to this from positive to a not positive number. So count will be 2. only because we have assigned these numbers or pre-inserted these numbers, we are able to identify, okay, these are some of the characters that were present in the T as well. Okay, so then J comes, then O comes. O is also -2 now. Then J comes, then D comes. D is -2 now, and then E comes, same, and then B comes. Now we are in this range from here to here. So B will be right now, it will be -1, and then A comes. A would be 0. This is not 3. Now from here to here. Okay. Now we can see it's from here. This is the I, and this is the J. This is the J. This is the second window. Now if the length of this window was less than this, obviously this is a greater than length than this window here, so this would be the minimum length as still remaining. Now we would move on to, again we would move on to I here, and then calculate till here, should be again this length, and then when we come to here, then we'll get a better kind of length, but again we would be here same, and then we come here, then we get a much better a much better lesser length of window, lesser length of range, I would say, not window here. This is much better, but now also we have another length that still remains, that is this BANC, which is the actual answer, which we're going to get eventually, obviously. But and if I tell you the pseudocode for this would be for int I equals to 0, I less than the length of the s string I plus plus. Then we created a hash of 256, fill it by 0, and then we're going to, now by the way, I am writing all this code in kind of like a pseudo code for JavaScript. You can use any language, and then I'm going to fill the hash by iterating from T for j equal to 0 to length of T minus 1, and I'm going to say, okay, so the character, the T j, the hash is plus equals to 1. Okay, now here again I'm going to loop here for j equals to 0 to length of s minus 1, and I'm going to say, okay, whatever the character I get here, I'm going to put it inside of my hash, and I'm going to reduce it by 1. I'm going to reduce it by 1, and when I reduce it by 1, I'm going to check if the hash is equal to 0, because that's only I know. I'm going to break here, and min length equals to min j minus I plus 1 min length. I'm going to break it. Okay, I'm going to break them, and I want to calculate the min length. Okay. Okay. So now this was the second approach. Let's come to the third approach. This question. This is a difficulty of hard, but if you understand the sliding window well, this is a medium question. But what was important was to understand the approach of this question. Now again, let's take the fourth string again. Is this. Okay. Now here, let's analyze first our second approach. So second approach, if we analyze this, we can see that okay, I'm moving till n minus 1 here, and then I'm moving to n minus 1 here. So the time complexity for this would be O of n square, and the space complexity will be O of 256. This is still, we can definitely optimize it, and we have to optimize it now to n O of n. So the string again is A, P, O, B, E, C, O, D, E, B, A, N, C. All right. Why is it so much? Yeah. Okay. So this is the S string here. Now we're going to use not a hash like before, but a hash map, a hash map. Okay. So here, starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay. So now we're going to once again iterate this part here, and A is 1, B is 1, and C is. Now here you actually don't need to, again and again fill the hash. We are going to optimize this approach and use a concept, the pattern, which is a sliding window. So let's start L, R, and first, obviously, what you should be knowing about the sliding window pattern, that R is for the expansion and L is for the shrink. Okay, so in a normal for loop, we first expand, and inside of it, based upon a condition, we shrink. Okay, so let's try it out now. Let L equals to 0, R equals to 0. Okay, now while the R is less than the length of S, we are going to do some calculations. Okay, now we're going to see, okay, so the character here is A. So now we're going to check and subtract, just like the previous one, subtract from 1 to 0. Okay, and increase the count from 1 to 0 to 1, because it changes from positive to a negative number. So here it would be that character equals to S R, and we're going to the map, and the character would be minus equals to 1. And if the character is equal to 0, if it's equal to 0, we are going to count plus plus. Okay, I think did I do some mistake here, because I didn't check for the condition that, okay, I only did the 0 part to check the condition, and I haven't done one thing here. Okay, this part I did wrong, guys. This was wrong. Here we're going to count plus plus, and if the count is equals to length of t, then we are going to do the min length, did the min length, and do a break statement here. This was wrong on my part. Same goes with here. We're going to count plus plus, and if the condition here is if. Now we're going to do a while loop. Why? Just understand this. Okay, so A is 0. We're going to change the count. Okay, simply we're going to increment the r. So let's write it down here first. So r plus plus the loop ends. I'm talking about the outer loop. Okay, I'm going to increment. So d is again -1. O is again -1. Then b comes. If b is 0, this becomes 2. Then e, then c. This becomes from 2 to 3. Okay, from 2 to 3 it becomes. Now as it is equal to the k, first we want to update the main length variable. This is going to be r minus l plus 1, so that is 5 minus 0, 5 plus 1, 6. Okay, this is the length. Now this is going to be our window size. Going to be our window. Okay, this is our window. Now we are going to shrink the window. Why we are going to shrink the window? Because there could be a chance that we can shrink the window. Like there can be a chance, right? Like let's say we have B, then we have E, G, then A, B, C, F, H. Now let's say your L is here and your R is here. But obviously this can be shrinked, right? This can come to here. This can be shrinked more, like here, and even more to here. So how do you identify that? To identify these things, we have to shrink and check if still we have the count fulfilled or not. Okay. So I'm going to increment my left here. So now I'm going to say while count is equals to length of t, we are going to increment the L plus plus, and we're going to say in the map with MP, we are going to say, okay, S, L, and plus equals to 1, okay. And if the map as L is positive, now if it's positive, then we are going to do count plus plus. Okay, now here there's a problem here. It could be that let's say you have A0, B1, C1, and let's see over here BBA. Okay, BBA. This is all let's say this is over here and left was here, and then you basically subtracted everything. So this became 0. This become, let's say, -1, and this become, let's say, this would only be not be -1, but let's say this becomes 0 only because this was too big before. Let's say it's A, B, B, C. What I'm trying to tell you is that this can go wrong with this kind of a situation. We need to know exactly show that it changed from 0 to 1 and not from 1 to 2. It could be right that if it become from 1 to 2, right? But even then, if it is positive, if it from 0 to 1, from 1 to 2, even if it becomes like that, we know that it was in the T string. That's why it doesn't matter. That's why we're going to count this thing here. That's why we are going to count this thing here. So here, as we have incremented the count here, so MP map is positive, we're going to count plus plus, and if the count is now equal to the length, we're going to say now it's not equal to the length. Actually, it's not actually equal to the length. So right, I have to here I could not do this plus, but we have to do minus. Yeah, minus. And now if it's not equal to be less than, so we're going to break out of this loop and then again expand the R here. So it becomes 1 DOC here. And now we're going to increase the a, so this becomes 1, and now it is positive. Now this is positive again, so we're going to increment by 2, and we're going to say okay. Also, yeah, it was good. Now we're going to again go to O. Let's do this much in a batch better with to understand what's happening. A ADOBEC ADOBEC ODEBANC ODEBANC A1 B1 C1. So here we have here, right? L is here and R is here. Now that it's become 0, count is 3. So we're going to shrink this. This got changed to from 0 to +1. Again, it became +1. Did I do a? Yeah, I did. I have to change this this here to minus, and this should be also minus. No, this should be plus here, and this should be it should be minus. Yeah. Now it has changed from again become positive, so we're going to stop shrinking our array, and then again increment the R here. Okay, so O is -1, D is -2 here, O is -2 here, E is also -2 here, and then B comes. So B now it is -1, doesn't matter. A becomes 0. So now because okay, so I forgot to change here. When inside of our range, when the A character changes from 0 to 1, when we increment it, we also have to decrement the count variable. So from 3 it becomes, and now that we are including A here, now because we left out A before, now including A here again, we're going to increment it to 3 as it is changed from 0 to, okay. Now this would be the new length. Now we're going to start shrinking it again. So L doesn't matter. Now we are here, doesn't matter because it's now this. If we do here, now B would be changed from -1 to 0. Doesn't matter because we still have a B here. And then here doesn't matter. Here, now the C becomes from 0 to 1. This would be again 2 here. So now we don't have the C here. But increment the N, increment the C again to the C here, and now it becomes from 1 to 0, and then count again becomes 3. Okay, again becomes 3 here. Okay, and again we're going to shrink T, E, B, and B now is, let's say, even here. Now every single time we are basically shrinking, what you can notice is that the count is still equal to the T. So we have to change the min length variable. Right? So every single time we're doing this. So min length. So after we have implemented the L++, so not even there, you can just do it here as well. Min length is equals to, because we need to verify the condition as well, right? After it has been implemented. So that would be R minus L+1. We again change the statement here. And we again update our min length variable. Yeah, that's it guys. This was the problem number 76 of the LeetCode.